So I know it's testing techniques in Go, right? But I also know that resources on how to the mechanics of testing are widely available, right? A lot of people who are much better speakers than me, much better teachers than me, have gone through copious talks. How do you actually test, right? So we definitely are going to go through some of that, but it's more the approach, right? Some of the stuff is a little harder to just read about or harder to show on a screen. That's really where we're going to focus on the approach to testing, how to test, where to test, things like that. We have a newcomer in the back. Put you on the spot. Your name?
Philip Day.
Philip, nice to meet you. What do you do?
I am a test lead here at Ultimate Software.
Fantastic.
Yes.
The fact that you haven't met yet means that maybe my code hasn't broken yet. Yet being the operative word. We're going to wait just a few more minutes. I told Joe downstairs that we weren't going to really start until about 7:20, 7:25, just to give people a chance to come
I have
here.
a question for the audience. Like, what's screen code?
Coding bootcamp. It's an intensive accelerated learning program that teaches you the coding front end, back end.
Is it like a virtual class or
It's like live lectures.
you go to a place and so you guys know each other?
Oh,
Yeah.
Yeah.
It's located at a Fat Village in Fort Lauderdale, and
You have a teacher, like an instructor. that-
we have 3 instructors full time with us during the day, and then we get teaching assistants at night. And so we go through the whole thing. Like this first 2 weeks, we're doing Ruby, and then just straight Ruby language. And now we're coming up into testing. We're gonna do Rails like week 4 and JavaScript and things like that. So eventually, it's just gonna expose us to everything. And
How
we have
many
a,
hours a week are you putting into it? Sounds like you mentioned like even
No,
days.
man.
10 a.m. to about 3.
I've only spent like 5 hours every day since I started. So that should tell you something.
Yeah. It's great.
It's fun. It's kind of fun. It's fun. It's dynamic. It's no painful.
Is it working for you? Like you feel like
Oh
Yeah.
big time?
I think it's just trying to get the brain to make connections through oversaturation, and eventually it does. It's just, you just got to trust your brain to make those new connections at some point. Yeah, it's fun. Try it out. Tell me what you think.
Thank you.
Welcome. Welcome. Going around the room. Is that
I'll wait another 5 minutes. and then
we all 5
Oh,
minutes? So price of entry is just your name.
Four-year expensive version.
Hi guys, my name is Sasha.
Where the majority of it was not needed.
They can skip all the
Thanks.
And Brian,
What to do.
Brian, you guys are fantastic. What do you do during the
Yep.
day? Sorry? What do you do during the day? Do you do music? What do I do during the day?
He's also in Winco.
Oh, you're also in
He
Winco?
was in our class. We just finished a couple weeks
We're all
ago.
gonna leave tonight.
We're all looking for a
I don't
plan.
usually ask people what they do, right? Because then at work or whatever, just how do you spend your time? That's more
Do
important.
you have an assignment? Like go to the
No.
and it gives you
We're just
grades.
excited to
That's good. Passion is absolutely critical when it comes to software, especially because sometimes you just can't figure it out, and you just have to keep going and going and going until you figure it out. And we don't always have the luxury of saying, I don't feel like working on it, right? Big deliverable tomorrow, boss is coming, like you got a customer waiting, you can't just not figure it out, right? So sometimes you have to come up with new approaches, take a break. You can't give up, right? So that passion is absolutely critical. That's what keeps you going. It's sometimes when the problem's a little boring or a little slow, it happens, right? It's not all shiny things and robots and flying saucers and stuff. So definitely important to have that passion there to help drive it. So
Nice.
Carl's interrupting me.
I was not talking.
Okay, I guess we can go ahead and get started.
Yeah, let's roll.
Okay, so as I said, we're gonna focus a little bit more on the spirit of testing, what it means to test, the approaches to testing, how do we determine our boundaries, different testing strategies. Welcome, another win coder. Very cool. Full house. how do we organize our tests? Where do we test? Where are the boundaries of our tests? What should our approach to testing be? Does it mean writing code to do the testing? Does it mean writing things out? What does it mean? What is this ID concept of testing? And we're gonna do some Go examples and frameworks and things like that. So should you be using a framework? What framework should you use if you are? All decisions that ultimately are up to you and the team that you're in. So one of the things, tenets that I believe in is this idea of software craftsmanship, right? So before we can go into that, we have to understand what is a craftsman? What do I mean by craftsman? What is craftsmanship? So the definition is just a member of a skilled trade, someone who produces a craft, an artisan, artist skill. That doesn't really tell us anything. What is a craftsman? When you think craftsmanship and a craftsman, what do you think of? Do you think of the stuff you build at IKEA? Probably not, right? That stuff falls apart. You don't think of that as craftsmanship. It was someone who takes care, pride. They spend a lot of time and energy in doing things the right way. Not because they have to, because that's the way it needs to be done. A fantastic example of that is a friend of mine, a long time ago, he was learning to make furniture, right? Going to be a wood craftsman, right? To do woodcraft. And every single day, at the end of the day, he would have to clean up the shop, regardless. There would be no sawdust allowed on the floor. And then his mentor would go and check things. Why is the sawdust? He'd pull it apart. He would take the guards, there's sawdust in here, clean here too. Like, what's the big deal? It's just sawdust tucked behind. But the idea is that level of care that you give to your tools, sharpening them before you use them, cleaning up afterwards, that is the way it should be done, not because a customer expects it, because that's the way that you expect it of yourself, right? And that's craftsmanship. And we see it in very high quality things. You want to buy craftsmanship, you pay for craftsmanship, and that's something that's unique, right? Not everyone can deliver that. So software craftsmanship, if you guys haven't heard of Uncle Bob, you will soon. He's very well known in the Ruby community, especially, and anywhere else, big in object orientation. He has a lot of fantastic articles about what it means to be a programmer and the idea of craftsmanship. So he's one that says that software craftsmen are professionals who believe that at their core, that the absolute best way to build software is to build it well. Right? Don't put up crap. That's what matters, right? People want to build your software. It needs to last when you're done with it. When you're no longer working on it, it should still work, right? That there can be reasonable assurances that it is going to continue to work and do what it's supposed to do day in, day out when you're not paying attention to it. So one of the tenets of a software craftsman is that we take responsibility for the correctness of our code by testing it thoroughly. And we don't tolerate preventable defects, right? I don't know if you guys have ever tried to divide by 0, preventable defect. If you ever are divided by 0, you messed up, right? That's something that you could prevent. That's absolutely something you could prevent. It should be tolerated, right? Don't tolerate it amongst yourselves. Don't tolerate it amongst your peers. Don't tolerate it at all. Because as a software developer, as an engineer, as a craftsman, it's just not appropriate. So with that in mind, what does it mean to actually test, right? Before we can even go into software testing, we understand, how do you test something at all, right? How do you know that something works? Right, that's ultimately the question that we're trying to answer when we test. And before we go there, there's an announcement I want to make, a little bit of legal mumbo jumbo, right? You're not your code, right? It's a lot of times a typical story that the QA engineers and the test engineers don't get along with the software engineers. Why are you finding bugs in my code? You hate me, right? And then the QA guy is like, why are you breaking bugs? You hate me, right? The fact is, bugs are there to be found, right? We are not perfect people. There's no such thing as perfect code. The most perfect code in existence has, I think, 2 bugs in it, and that was for the Apollo NASA program, right? To get spaceships. that's the level of perfection. They still had 2 bugs found and tested, but we're not NASA. So, and just make sure to remember, you are not your code, and don't take it personal, right? We're all working together on the team. So what is a test? Now we can answer that question. A test is a written down series of steps to exercise a system to ensure its contracts are fulfilled. I don't necessarily have a source for that. It is the definition. That's what I consider a test, right? I don't care if it's code that actually executes it. I don't care if it's a person that executes it. I don't care what it is. It has to be written down, because if it's not written down, it won't be remembered and it won't be done again, right? Part of testing is repeatability. You should be able to execute those tests over and over again. And sometimes things can't be automated, right? If you're testing a device driver, right, and it's for a printer or something, some physical thing, and you need to test what happens when you pull the plug during a print job. I have to, I'm on call. I apologize.
Oh.
I'm actually,
Can I take that away?
yeah, hold on, please. Thank you.
Good thing he's on your team.
I know, that's fantastic.
They came.
Oh, they hung up?
Yeah. All right,
That's cool.
no problems. It's all good.
They'll go to the secondary.
Speaking of people not testing their code,
I know.
let me see if I.
No, we part of what, as an aside, part of what I do day to day on the platform layer is we provide the servers, right? We help people deploy and tests break. And sometimes our code breaks. Sometimes the marriage between the code, our code, and others' code breaks as well. So we're responsible for that. So that's why a test is a written series of steps, right? Because you can't put everything into code, right? The most brilliant engineer in the world can't put everything into code. You want to see how something behaves when you unplug it? The only way to test is to unplug it. Maybe that means building a robot to unplug it. I don't know. But that's just to improve the speed of your test. It's not necessarily to stop you from having to test. Here, Piloto, do you mind?
Yeah.
Thank you. All right. But if you can automate it, you probably should, right? Because you're going to be running these tests a lot. Because you're going to write code a lot. You don't want the worst type of bug is the bug that comes back, right? Because it's preventable. You've already shown that it's preventable. And if it comes back, you clearly weren't doing your job. And I'll say a lot of extreme things, like you clearly weren't doing your job. Not being personal. I'm harder on myself, right? I consider it, I'm incredibly angry with myself when I screw up, right? No one's gonna have a higher tolerance for my work than me, right? And that's part of being a software craftsman, is that you care more than your customers, right? And in order to determine whether your tests are actually testing everything, Go gives us some fantastic tools, right? It comes with code coverage built in, part of the native testing tools. And it's important to keep in mind, while metrics are important, they're not the ultimate answer, right? That just because you get 100% code coverage, which, just to make sure we all know what code coverage is. So code coverage is when you write your tests, you essentially instrument the code that you're testing. The tools do it automatic. You don't have to go and check every line. And it basically just checks that every line was executed, or counts the number of lines that are executed and traces their execution. So you can check whether or not the code was exercised by your tests, right? So that's how you can find sections of your code that are not tested. That's how you can find things that are under-tested or potentially over-tested. Those are things too. You can over-test, right? You can find hot points in your code through code coverage. But it's not just because you have 100% code coverage, just because every single line is tested doesn't make your code better. It could make it worse, right? It could, because your tests could become brittle and you become in a situation where now you can't change anything because all your tests will fail, right? And one application that has 50% coverage isn't necessarily worse tested than one that has 80%. It's all based on context. So it's important before worrying about what these metrics are, just keep that in mind with any metric, whether it's lines of code, whether it's cyclomatic complexity, how complicated your code is, it all is relative, right? The simplest piece of code, the most perfectly well-written piece of code is an empty file, right? You'll have 100% code coverage. You have the fewest lines, you have no complexity, but it's worthless, right? And some things are just too difficult or so unlikely to happen that it's not worth the energy to try to improve that number, right? Because at the end of the day, our job, amongst all things else, is to deliver business value, right? And we can spend all day testing, but if we're not delivering business value as a result of that testing, it's not, right? Because we're going to go out of business before we have a product. And this is what some code coverage, what the tools in Go actually output. You can see green is stuff that was passed over, that was actually executed. Red are things that have not been executed. That's pretty good. And maybe you decide that this last case is something that's so rare, right, that it's the operating system failing, right? You have it there because it's due diligence. It's probably not going to happen. And not only that, how difficult is it to make it happen? If it's something trivial to make happen, you can get that, go for it, right? But if it's really, really hard to make it happen, and it only happens once in a blue moon, maybe it's not worth it. It depends on your application. And like I said, you're not NASA. Maybe you are. Maybe you're writing code that controls cars, right? You don't really want to have all the horrible things that happen with Toyota, where suddenly the car just veers off and runs away. Turns out that was a problem in testing. They had a buffer overflow that basically caused the car to think it was slowing down. And so the government kicked in and made it go faster. Didn't matter how hard you press the brake. That's something testing should have caught. That matters. Lives are at stake, right? If you have software that's running inside of a human body, it matters, right? Take the extra step, take the extra care, do your best, be extra careful. But we're running a business. We're not running, we're not surgeons. So it's really a matter of reducing that risk. So if you check with your tests, you say, okay, I'm willing to risk this not working, right? The business can handle that not working. What's the worst thing that could possibly happen? Someone can't log in for 5 minutes? Okay, maybe that's okay. Maybe it's not. It depends on your business. It depends on the use case of your customers and use case of your software. And that's important to keep in mind with all of these techniques, is that you have to balance the desire to test and be perfect with reality, right? That's something super critical. Always keep that in mind. The way that NASA actually gets near perfect code is for every single line of code, they have this much documentation and planning. Weeks and weeks and weeks of documentation, rooms filled with it, right? And businesses can't run like that. That's why it's run by the government. And I assure you that SpaceX doesn't have nearly that much documentation, because at the end of the day, they have to make money, right? And lives still are on the line, but it's different, a different amount of risk. So now you have an idea of how to test, where to test, right? And what tests are. What are the different kinds of tests? All right, we're gonna dive a little deeper, right? Okay, test, wonderful. What's that? There's all these different kinds. You'll hear terms unit tests, integration tests, acceptance tests, smoke sanity tests, regression tests, A/B tests. It goes on and on and on and on, right? There's so many different variants of testing. And a lot of them are kind of wishy-washy what they are. What is a unit? I don't know. What are you integrating with? I don't know. It's really just a matter of, again, the context of your application. So I don't like using those terms because they're too overloaded, and any two people can have different ideas of what a unit test is, different ideas of what an integration or acceptance test is, right? I use the terms cheap or fast, or expensive and slow, because it's about getting faster feedback, right? We test so we can get feedback. You change something on a web page, you go and refresh it. That's a test, right? It's not automated, that's fine. That's a test, it's getting that very fast feedback. But a lot of times when you're dealing with complex algorithms or multi-step processes, it can take a while to get that result. So you want to separate out the types of tests you can do very quickly from the types of tests that you can't, and the types of tests that are cheap. And by cheap, maybe it's talking to a database. Maybe you consider that cheap for your application. Maybe it's printing a piece of paper. That could, for that application, be cheap. It also could be incredibly expensive. That all is based on the context of your application, the context of the code in which you're writing. And the testing package built into Go seems to agree. There's a flag that you can set when you're running a test that enables this function to return true or false of whether or not the person running the test requested a short test. In which case you can branch in your code and say, hey, this test, I know it's long, so if they ask for short, just skip it, right? We use that for when we're doing, depending on the application, for some things we're testing actual HTTP requests to external services. Those are incredibly expensive as far as time goes, right? Or if we're creating and destroying things in the database, incredibly expensive as far as time and resources. We have to spin up a database in order to test, right? So we still want to perform those tests sometimes, but we want to get that feedback as quickly as possible, because if we run an expensive test, but we have a failing quick test, that expensive test was a waste of time, energy, and money. And the most important thing is your time in these situations. Testing saves you time. I know it doesn't always seem like it. You're like, why do I have to write a test? I just wrote the code, I tested it works. But you don't know it's going to work tomorrow. And that's what tests help do. So by separating out the speed and the expense, you now can get that balance. You can strive for that balance of quick feedback with total system working, right? You can ensure that you meet the business needs of your customer, whoever that may be. So there's a lot of indicators. These are generalisms, right? There's no hard and fast rules. Again, it all is context driven. But cheap and fast tests generally aren't requiring an external resource. If you're in the microservices realm where you have lots of little services talking to each other, you may not be talking to all of them. You may be talking to a subset of them. You may be talking to fake versions of them that have a pre-canned response. You can use in Go HTTP test server. It's part of the testing package to actually build these little fake servers. And so you just pass that as the URL you want to talk to and have a preset response, right? So that's much faster than talking to an external service. Whereas when you do the long version of that, you would talk to the external service. They're generally self-contained as part of that not having externals kind of thing. These are most in the realm for most definitions of unit tests, right? When someone says a unit test, they're generally talking about a cheap and a fast test. These are also the types of tests that you usually can throw away most easily, right? Because once you don't need to have hundreds of these things. If you can get rid of them, they're there because those tend to drive the implementation details, and you want to try not to test those. You want to test your contracts. That's what's important. And the expensive ones tend to do that. These are also, if you do have a CI pipeline, a continuous integration pipeline, these are the first ones you run because they're cheap and fast. The faster you can get feedback, the faster you can fail, the faster you can fix the problem, right? And when you have a complicated problem to solve, if you can get the answer very quickly, that's much better. And expensive tests, like I said, they generally execute are external resources. They generally are testing multiple components at once, right? Again, it's up to you as the developer and the engineer in the situation to decide what is a component, what are all of these pieces, but they're generally going to be expensive and slow because you're testing a lot of things at once. You may be impacting systems or external calls, and that's all depends on the application. It's hard to draw rules because, again, you could be a car, you could be a web app, you could be, I don't know, Twitter, whatever. You could be Yo, which is a strange app. And this is that flag I was talking about. So basically, if testing is short, skip it, and it'll just short circuit execution. And I'll have a nice little message saying, this test was skipped because of whatever, right? Or why it's long. And you can build on top of this with a similar approach. You can add additional flags. So you can say, okay, these are database tests. These are external tests. These are however you choose to categorize it. But the bare minimum, the testing package in Go provides short and not short, right? And a lot of people say, oh, you can never have too many tests. You can never have too much of a good thing. Ask any kid on Halloween who's had too much candy. It's not necessarily true, right? We have a math teacher in the room, very helpful for this example. So consider we have a couple of simple functions, right? Multiply and divide. How do you know when you're done testing it? There are lots of numbers out there. A lot. Think of the biggest number you could possibly think of. There's way more than that, right? And there's also way smaller numbers. There's no limit to the number of numbers. They keep discovering new ones, which is weird. I don't know how that works. So how would you know, right? How do you know what does multiply do, right? We have identity. We know the rules about zero. So generally, you kind of want to do a couple of the extremes, your edge cases, and a few in the middle, right? So in this, it's dividing and multiplying. We know kind of how those work from school, right? Multiplying, if it's multiplied by zero, it's zero, right?
That is confirmed, yes.
Okay. And if it's multiplied by 1, it's the thing. It's the whichever one that's not the multiplier. The multiplier. It's 7. But so. Okay. Yeah, it's the same. So 5 times 1 is going to be 5. So you can check for the identity. And since you said that you wanted to take floats, you want to take things with decimals, you should throw a couple of those in too, just to see how it behaves. But you don't need to test every number in existence, right? And when you're dividing, you want to catch the big ones. 1 divided by 0, you can't do that. So your system should probably fail. But notice we didn't say how it should fail, right? In the little outline of the code itself. We just say what it means to have failure. Does it return an error? do we decide, you know what, we're just going to return 0? Are we going to return -1? Are we going to panic? We don't know the behavior because that's not, the business hasn't told us what the behavior is. But whatever that is, that's what the reaction should be when we attempt to divide by 0. And we should test for that. And the same thing with multiply. You know, we only need to test a handful to be reasonably certain that it's working, right? We're not doing proofs. Right? I don't know if anyone's done linear algebra. That's where you do proofs, I think. Or no, that's not it.
No.
It's one of them.
One of the
Abstract algebra.
abstract. There we go. There's a lot of different classes, courses with proofs. Testing is not writing proofs. It's just showing that it works, right? It's trying to find those counter examples to show when it doesn't work. And that if you do get a bug in your code, you can write a test for it so that you never get it again, right? And so this way you can reproduce it. Because like I said, some of these things are multi-step things you have to do in order to even reproduce the bug. And to do it by hand is slow, it's painful, it's annoying, it's tedious, and frankly, it kind of sucks, all right? So why do we even bother organizing our code, right? Organizing our tests long, fast, right? Beyond just the feedback, right? It's because software is meant to live in the real world, right? It's meant to interact with things. It's put into a noisy environment. It's not the pristine environment of a lab. It's not the unique snowflake that is your personal machine. I cannot tell you how many times I've heard, works on my machine, right? You guys have said that at least once, right? Twice today. Okay, that's a low, right? I've done it so many times. It works for me, works in this one case, doesn't work in this other case. I mean, everybody has said it multiple times. So that's why that's, again, another reason why we test to help ensure that it doesn't just work on my machine, it works everywhere, it works on every machine, it works everywhere that it's supposed to run in the same way, or at least in a way that our business decides it's supposed to run. Maybe it's supposed to run different. That's okay, as long as it does that. And while we're talking about production briefly, testing is not just your code, right? It's not just, hey, my application works, I'm done. I didn't divide by 0, I'm done. It's also in the real world, it's about testing everything else around it, right? How do you log so that you know when things happen in production? How do you know that your application is healthy? How do you do that in production? I have no idea. It depends on your application, right? Maybe it means you were able to perform 100,000 requests a second. I don't know. That's up to you. It's also an important note, in Go at least, and a lot of other things that are doing network connections, close your sockets. I'll say this at every single time I talk to anybody, because I don't know of a single developer that has never been bitten by this bug. I've been bitten by it several times, and I know about it, right? So the basic idea, for those who haven't actually had to deal with sockets yet, is that you have a limited number of these things called sockets in your machine, right? That's how you communicate with another computer. And let's say you have 1,000 of them. If you don't close it when you're done, there's no more. Your application's dead, right? It's actually fairly difficult to figure out that that's actually what's happening. If you retry, if you don't close that, that is a whole category of problems that some languages are specifically designed to avoid that category of language. Problem. Go lets you do it, right? Go lets you not close your socket connections, right? Because if they, part of the designers of the language basically like, you know, we could stop it, but it would require a lot more difficulty when actually opening up that socket, right? So we're going to err on the side of giving a little more flexibility and ease, whereas applications like languages like Rust go way out of the way to make sure that can never happen, right? It really just depends. So close your sockets. That's my public service announcement for the day. Do it. I don't know any single team that's not been bitten by this bug. I don't know how many times I can say, don't always close your sockets. Beware of issues when booting up. Just because it runs the same one way on your machine and things happen in a certain order on your machine, the outside world is chaos. Absolute chaos, right? If you expect the database to be there, one day it won't. If you expect a certain file to exist, one time it won't. Right? It may happen a millisecond after you go to look for it, right? But it's the real world. It's dangerous out there. It's much different than being inside a lab. It's much different than learning how to drive, you know, on a racetrack. It's absolute chaos, and timing is a serious concern. So just be aware of how you would possibly test for that, right? yank the cable out when you're doing it, delete files as your application is running, try to abuse it, right? Your job is to find those unhappy paths. And also consider your configuration when you are in production. And I know we're talking about testing, but production, how do you configure your application to change that configuration? Just some production concerns. And when you are introducing changes, right, nothing is static. So you want to try to introduce one change or a few changes at a time with their accompanying tests so that you can be reasonably assured and reasonably certain that the changes you introduce cause the problem, right? If you change 400 different sections and all these different components, and you know what, while we're at it, we're going to change the operating system and the database, and we're going to, I don't know, now we're going to deploy into Turtle. I don't know what, like, there's so many different variables. If you change all of them at once, you'll have no idea which one caused the problem. So try to change as few variables at any given time, right? That's just some high level, because testing is not just, like I said, not just your code, not just that you can multiply two numbers to get the right answer. It's that in production you can do that. Where you make money that you can do that, right? So why did you even bother? So how do we determine our boundaries of our tests, right? When we have that math problem, it's fairly easy. The boundary is that inside that function. But when we're talking about an actual system that has dependencies, when you are dependent on an external library, you depend on another module in your own code, when you depend on another function in your own code, right? What's the boundary? Do you have to test everything every single time? The axiom I like to use is trust but verify. It's absolutely true. So if you're using an external dependency, just kind of verify at a high level that it works, that it does kind of what you expect. But there's no need to test everything inside of it, right? So if you are using a math library, you probably can be reasonably assured that they did a couple tests. Just go look at the source code. Yes, they tested, right? So do you need to do in your own application, do you need to test 1 + 1? No, right? You just need to test it. Okay, for what I'm doing, it works, right? And that's important because when you have a large, complicated system, it gets fuzzy, right? At some point, you start testing the language, testing the framework, and that's definitely important. But you spend all day doing that, especially in Ruby or Rails, where you're talking hundreds of classes, tens of levels deep, right? It's just not worth it to do it for you to do it. Granted, in some of the projects I've worked on, we have found bugs in Rails, right? But that's only after making sure that it wasn't our code, right? And reducing it to the smallest possible thing, because we at the high level have to trust that it works. Because if there's no trust, there's no why you're bringing in your dependency. A very big Go developer who used to be a Ruby developer who wrote Sinatra. I can't remember his name for the life of me. You guys probably will be exposed or have been exposed to Sinatra. He said, you wouldn't just pick food up off the floor and eat it. You shouldn't do the same with your dependencies, right? So it's kind of the same thing, is that you should trust that they work, but just kind of verify that they do what you expect. And as soon as they break that expectation, either decide whether it's okay, right? Maybe it's okay to have a breach of contract there, or maybe it's not. It all depends on context. And so how do we determine those boundaries, right? Trust but verify. We have to remember what our external contract is, right? At the end of the day, for example, in Ultimate Software, we do human capital management, right? We do HR software. We do the calculations for people's paychecks, right? You can't mess that up. You can't mess up the taxes. That's not cool, right? People will be very unhappy if suddenly all their money's gone, right? There was a place that I worked where the accountant did it by hand, right? And she kind of messed up the positive and the negative. And apparently there's this thing that you can actually do direct deposit in the wrong sign. So she withdrew everyone's paychecks. That was fun. That was a fun week. Oh man, that was fun because people were overdrawn their entire paycheck. The company had all this money all of a sudden, and then it was a disaster. Needless to say, that company is no longer in business. So we can't make those mistakes, right? When we do math, we can't make those mistakes. So our external contract is to make sure that number is right. If inside of the implementation, some deep level thing has a flaw in it, that's okay, maybe. And maybe it's not okay, I don't know. Depends on your business. But it might be okay for that thing to have a problem as long as the number at the end of the day is right. That's what matters. Your external contract with your customer, with the consumer, with, if you have an open source project, it's that your external libraries, your external API remains the same. Or at least it changes in an expected way. And that's why you have to be mindful of your dependencies in this case, right? The boundaries of your application generally are your dependencies. Right? If I depend on a math library, that's a boundary. Right? I'm talking to an external, I'm consuming something external. So I don't need to really test beyond that wall most of the time, right? We don't need to make sure that it can correctly calculate pi to 10,000 digits. Like, come on, man. Unless you do, again, unless you're NASA, unless you do. So again, it comes down to that. So be careful with your dependencies. You don't have to test every line. The QA guys here might hate me for saying this, but you don't need to test every line. Because again, if you're testing those external contracts, right, and you're tailing your edge cases and things like that, maybe you don't need to test that line. Maybe you don't need to strive to try to test that one particular strange edge case that only happens once every 10,000 years when the sun aligns with the moon. It's not worth it, right? We're here to provide business value, right? So we have to balance our desire to be perfectionists with our desire to actually get paid, right? For the business to make money. And it's important to note if you do have too many tests, and I've done this myself, I've shot myself in the foot like this, it will make your code brittle. You will not be able to make a change because a little change here breaks all your tests. And now you have that same problem as not having any tests at all, because you don't know, why did this one thing break all these things, right? It should have broken a test or a couple tests, right? If you get back to that division problem, if your business decides, if the consumer decides for whatever reason that instead of raising an exception when that you divide by 0, they wanted to just print, you screwed up, bro. Maybe they changed it, right? All those tests should fail, but not every other test, right? That's reasonable because now you can go change the tests to what the business demands so that they fail and then go fix the actual code, right? And when you start doing that, you actually start getting into TDD, which is entirely, it's a religion. So we're not gonna go there, right? I myself am a follower of TDD. I'm a little addicted sometimes, I apologize. But the fact is, tests can make your code brittle, and that's not good, right? So if your code does end up being brittle as a result, you might want to refactor your code, your tests, and your code. And that, along those lines, tests guide your design, right? So when you're doing TDD or you're doing whatever tests they are, it's okay to have slightly brittle tests at the beginning, right? Because that helps make sure that the system is meeting its design expectations. But once you can have a higher level test that can test that properly, you might not need that anymore because that's, as soon as you change that implementation, you've broken that test. And at the end of the implementation doesn't matter. It's the actual business contract that matters. So in that case, going back to that math thing, if you decided to do some really cool formula, right, to do adding and subtracting, I don't know, maybe there's a cool formula, right? I'm sure someone has a very convoluted way to do math, right? I don't really care, as long as at the end of the day, 1 + 1 = 2, right? That's what matters. But if you tested that convoluted algorithm and you have all the tests that guided the design of that convoluted algorithm, as soon as you deviate from that, everything breaks, right? And why? The business wasn't impacted by that decision, only your choices. And that's really what's important. And the reason, right, that we let tests guide our design and when we do these sorts of things is that the tests ensure that they work today, they work on my machine, and they'll work tomorrow. They'll continue to work. Your code will continue to work regardless. And don't forget, tests are code too. You own it just like your regular code, right? I'm kind of opinionated in what I think of test engineers. Sorry, guys. But I think that if you're not testing your code as a developer, you're not writing code. If it doesn't have a test for it, it shouldn't exist. Because how do you know it works? How do you know anything did what it's supposed to do if you don't have a test for it? Right? It doesn't have to be code. It can be written down. That's fine. But it has to have a test for it. It has to have a procedure in order to test it. And then it needs to be refactored, refined, revisited, documented, just like your application. I've seen lots of tests that are inscrutable. I have no idea what they're doing. I've also seen really good tests that make it clear how the code is supposed to work, right? And Go helps us out a lot here. you can have these really cool things called example tests. And the testing framework has a lot of, the testing package, has a lot of good examples of these, where basically you can say, this is an example of how to use my function, my code. Its output should match this as a string. So you actually now get built-in documentation and examples. And if you use the built-in tool to do documentation called GoDoc, it'll actually show those in line as examples. So that consumers of your application can see in the documentation how to use it, right? And that's really, really cool. And so we get towards the end of here, we say, you know, one of the first things when you're doing testing, especially if you come from, let's say, Java or Ruby or a lot of these other highly opinionated tools with large communities behind them, the very first question after you decide to actually test is, do I need a framework? What framework should I use? Just like if you're doing a web application, one of the first questions you ask is, what framework should I use, right? In Ruby, if you're using Ruby, they'll say, oh, use Ruby on Rails, or use Sinatra, or there's a whole bunch of them, right? Same with JavaScript. As soon as you say, oh, I want to build a web application in JavaScript, cool, what framework should I use, right? So Go provides us a testing package, right? Just like everything else, Go strives to provide the kernels that you need in order to do the rest yourself. It doesn't do more than that, right? So it's not going to write your application for you. I'm sorry, it's not Java Spring, and it's not Rails. It doesn't do magic. So the tests will give you the ability to run them. It'll give you the ability to fail, to pass, to skip, to benchmark, to provide examples, but they don't do any more than that, right? There's not even an assertion. Right? A lot of testing frameworks have assertions. Assert this is true. Expect this to be true. Expect that to be true. Assuming you guys do tests with Rails and RSpec, probably, maybe, or test unit, you'll say assert true. A should equal B. We don't have that in Go. Why? We have if statements. So in Go, we use if statements. Standard library use it. You say if this expectation is not true, t.error or fatal, this failed, right? Why add something just to the testing that's already that's just an if statement, right? Ifs are your friends. I know in Ruby they tell you not that ifs are not good. They're fine, right? Just don't have too many, maybe. So, but there are some good ones out there. I make no endorsement of these. I've only used a couple. Go Convey is pretty neat as far as testing stuff goes. What I like about Go Convey is they actually have a command line tool that'll actually monitor your directory for changes in your code or your tests and will rerun them for you automatically. So you've got to get kind of built-in CI without trying. Like give you a nice little pretty UI too, with all red and black and green, like you passed, failed, with notifications. It's fantastic. It's really cool. You don't have to use their testing framework to use it. So I use the standard library with Go Convey because it's easier to run. That's a testing framework. Ginkgo is kind of neat. Go Mega, they're cool except for the fact that they use a Unicode character as their function, so you can't actually type it.
You don't have to.
You don't have to, but they're like, it's so pretty and cool. But because Go is strongly typed, and just because a type looks the same as another type, they're actually different, right? Plus, it's really annoying to type, and if you make your code annoying to type or read, shame on you. That's not cool. Code is written once and read many times, right? So it needs to be readable. There's GoSpec and Testify. Testify does a whole bunch of things that you expect a testing framework to do. It has mocks and stubs and things that, whatever, I'm over them, right? You don't necessarily need those things. And I avoid even using stubs where I can because now I'm not testing the real thing. I'm testing an imitation of the thing. In fact, we had a project I was working on with a couple of guys. There was one person on the team who loved his stubs. He loved them. He would stub everything. So I said, watch this. I went to the code and deleted all of it. Test still passed. Right? It shouldn't happen. Right? That's called a mutation test, also very important, where you just willy-nilly change the code. And tests are supposed to fail in that case. You're making sure the tests are actually executing the code. Right? It's super important because who watches The Watchmen? Right? Awesome movie, great comic book. Who watches The Watchmen? Who tests your tests? Ultimately, you do. Right? That at the bottom. Did you know there's a radar detector? It's a thing. I'm not just stuttering, but it's a thing because both sides are trying to detect the other. So in this case, our tests are trying to find bugs, and our code is trying to find tests. All right. So that's the important job. So I want to open it up a little bit, just because that's what we're here for, right? Let's start with questions, comments, concerns. Go ahead, Piloto.
Do you know the application owner of this server that is down there?
That's SPS. I don't know the application directly. That's Lenny's server. He's the manager or tech lead for it. They should be able to redirect him to the app owners team.
What's his name? Lenny?
Lenny Grenos.
Okay, yeah. Right.
Poor pilots has to do your job.
Yeah, I appreciate it. No, that's
it's okay,
teamwork.
man. It's okay.
Any non-production outage related?
Said earlier that you shouldn't test everything under the sun. Some things only happen once under a blue moon, and it's not worth definitely automating. Could you recommend any lightweight alternatives to writing a full-blown test case, like any sort of system of documentation, just writing a little note, like in case of catastrophic failure, this might be the cause?
That works, right? Maybe it's something that happens so rare and the business can tolerate if it happens, right? That documentation is a fantastic case. Once we saw this thing that kind of happened, we never made it happen again, but it's here in case it does. Once we're able to actually reproduce it, part of testing is to be able to reproduce it. If you can never reproduce it again, how do you know what actually happened? That's my answer, right? I hope I'm not stepping on toes there.
All right, but any tips on like a lightweight standard way of making those little notes so that they're seen, maintained, etc.? You know the service that would accommodate that?
I don't. GoDoc is probably your way to go. I would just put a comment really at the top, or a text file called Here Be Dragons. It's as long as in your code that you write, it's consistent, right? Part of things are that things are where you expect them to be, right? So I've got this pile of weird anecdotal bugs that kind of happen once or twice, and this may be the solution because I've actually run into issues where we don't know the cause right away. It's a complicated system, but every time that it would occur, we'd chip away a little bit more, and it could take months to chip away at that problem. But eventually, you narrow it down, and be like, okay, now I've got it, right? Because it happens infrequently enough that you can't really find the cause, right? You can't reproduce it very well, but you do see that it does happen, right? It's real. They're not just imagining it. It's not a Heisenbug. Those are the worst possible bugs ever are Heisenbugs. But as soon as you go to look for them, they're gone, right? So it's really just being consistent in whatever the team that you're on, the code that you're writing, document it somewhere, anywhere. Put it in the README, fantastic place, or in anything, right? If the team doesn't have something, put something. Put a bug in your thing and saying with a label saying blue moons. I don't know, anything. We've run into those, and we do our best to just write it down in a text file.
By the way, excellent presentation. Just one thing I will add to it, you always gotta test for race condition.
Absolutely.
And some people don't agree with this, but I normally have the test package as a different than the package of the code.
Right.
Because that way you concentrate on the contract,
Right.
not on the details.
Right. So in case you're not super familiar with Go, the idea is every directory acts as a package, and that thing has a package definition at the very top, right? So if your package is, pizza, right, and you're testing the interface to pizza, you can actually make that your tests are in a separate package called pizza_test. And so now you actually have to import your pizza package, and you only are allowed to use exported things. It actually is a fantastic way to ensure that you're testing the contract, not the implementation, because you can't. The language will not allow you to reach into those individual functions to call them to see how they work, right? Sometimes you can't do that, right? So sometimes you need to test at a lower level. You need, for safety reasons, you can't do that. You're testing let's say you're testing a database, and you want to make sure it doesn't actually connect to the real database, you might have to be in the same package. That's just an example off the top of my head, but that's important. And if you are doing anything involving concurrency, or you think someone might, check for race conditions. Go makes concurrency like a first class concept, right? We have Go routines to allow you to check things off. There's the sync package to help orchestrate these things. There's channels to communicate. But concurrency is really hard, right? I mean, really hard, and it's mind-bending. It seems simple on the surface, but the idea, just like we said, in the real world, files just may not exist. If you try to read, if two things are trying to read from something at the same time, or while something else is writing, you could have all sorts of weird things happen, right? The possibilities are endless for what could happen. It could crash your application. It could do nothing, best case. It could, I don't know, blow up the world. Who knows, right? If you're writing code for nuclear launch codes, you probably want to check for race conditions, right? Or in the case of Toyota, you need to test because it could be that if you turn on the blinker while pressing on the gas and looking to the left, that, I don't know, the car just turns off, right? That's bad.
There's a race condition checker in Go.
Yes.
So that's a very helpful thing. It'll be like you might be accessing this variable and reads and writes in a weird order. So
Yeah, it will attempt to find them. And that's definitely going to help. You just pretty much pass the race flag to go test.
Yeah.
And that helps. It's also just important just to kind of think about ordering of things. Go routines don't happen in a guaranteed order, right? That's super important. And when you're accessing stuff from the database, the race also detector won't find, let's say you have two things, reading and writing from a table and database at the same time, right? That's on you to try to find out. And then conceptualize what it's actually doing and try to think what happens if you just change the order.
also for race conditions, there's the HTTP like debug package, which will give pprof, which will give you an endpoint that will spit out a lot of metrics as well as a stack trace of all your existing Go routines, which I've used to find race conditions for. When the whole thing hangs up and you're like, what's going on? You spit it out, you see a bunch of things that are like all sleeping on this one lock. You're like, ooh, there it is.
Yeah, you also can
Very
use the I think it's runtime package to
Yeah.
actually do inspections of the runtime as you're doing it.
Yeah.
So in one instance, we were having an application that needed to connect to an identity server, not yours. But basically an implementation of something that provided identities in order to find out whether or not a person was allowed to do something, right? And what ended up happening is we'd be like running it. Sometimes it would run fine. Some people's machines, it would crash. It would just act all strange. So what we did is we set up a Go routine that every so often would dump out to the screen the number of Go routines that are currently executing. And we saw it just increase, right? Again, sucking up all of our sockets. That was the problem. We didn't close our sockets. And in fact, it's a whole category of problems, that socket problem. Anytime you depend on an external API, include a timeout. Because if you don't, you basically let someone crash your program at any time. Because let's say we do a lot of web stuff, so a lot of those examples are going to come from there. But anytime you're talking to an external thing, include a timeout. Let's say I'm consuming his service, and he decides to pick up the phone, right, and never talk to me again, right? I now have a socket that's sitting there waiting forever and ever and ever. And then if I have to call him multiple times and he's still having problems, my application is going to die. And nothing's wrong with my code, right? But I don't have a timeout there. So I basically let someone break me at any point in time in the future, right? So if you're ever communicating with an external service, timeouts are your friends. There's even a cool little package called GoRec that wraps the HTTP request package to let you do that very easily, take care of that for you.
Spoke earlier how during development it's actually okay that your tests are a bit brittle, but as you stabilize, you should refactor, rewrite such that it means something when they break later on. Only a few should break. My question is, when you're developing, these are more development tests. You're not trying to prove anything. You're just trying to prevent regression more than anything and prove that work step by step. Do you have any advice for when you go back and refactor and try to sort of upgrade them from development tests into tests that help with regression and tests that at a higher level test contract?
I think you hit on the head right there, right? If it's something that's testing the contract, it needs to stay, probably, right? If it's something that's testing an internal implementation detail, it could go away, it could not. It depends. If it's really tricky and that thing is particularly flaky, maybe you keep it around for a little while, right? In fact, in Go, the full spec is available. and the implementation, the current Go, when you type Go in your computer, actually is it's an implementation of that spec, right? So you're not supposed to write to the implementation, right? You may know that because of the way that the Go compiler happens to be written today, doing this thing is good. But if you're violating the spec, you'll get in trouble later, right? So it's important just to focus on the concept of what it's supposed to do as a cohesive whole, right? And it depends on your application, to be honest. If you're testing deep internals, I don't know, maybe you can just delete it entirely, right? As long as that functionality is still, when you remove that test, being tested somewhere else. Right? That's what the code coverage can tell you. It can make sure that it's still being exercised elsewhere. And if it's being exercised by a higher level test, it's not necessary.
All right, follow up. Is it okay to test for regression and that a contract is being fulfilled in the same test?
What do you mean by regression?
Let's say you had a bug, you fix the bug, you write a test to make sure it doesn't happen again, or if it does, you immediately know. As opposed to something that's testing a contract, it's supposed to work this way, etc. Should those tests be separated? They're conceptually for somewhat different things.
Like everything else, it depends, right? So in that case, I would say, I mean, anyone else is welcome to chime in, right? It's not just me here. But to me, part of that contract is not having a bug in it, right? If you're able to modify the test a little bit and ensure that the bug doesn't happen, I would say it's okay to have them both together, right? One of the approaches in Go is a table-based test. So with a table-based test, you essentially have a whole list of test cases in a single test. So if in order to prevent that bug from happening again, it's just a matter of updating that to include an additional test, that's a win, right? You don't need to have a whole separate test. You still prevent the bug from happening again. And it's the least amount of changes to your tests, because at the end of the day, tests are code too. So, anything else?
Okay. So, what frameworks does Go test? Not frameworks, like what, if you're running a Rails application or a Ruby application, like what is it test for? Or is it just testing what you're
So the testing package in Go is more equivalent in the Ruby world to something like RSpec or test unit, right? It's just providing you the mechanics of testing, right? So it gives you the ability to execute a block of code and tell the runner that it failed, right? It makes no assumptions. It can't know your application, because at the end of the day, the only thing that makes your application is your application. That was horrible. Sorry, but like it's true. The only thing that makes your program unique is your program, right? So there's no assumptions that anyone can make as far as how your application works that would take that away from you. Right? The only person who can know how your function is supposed to work is you, or at least at a high level is whoever decided what it's supposed to do, right? If you're supposed to calculate payroll and you know that given a tax rate of X and a paycheck of this, it's supposed to be that, and the federal government says that's what it's supposed to be, then that's who decided how it's supposed to behave, right? So you can't differ from that. But as far as no one else, like Go can't, no framework can decide that. So essentially, Go gives you the tools to kind of build your own framework, right? Decide what matters to you.
I had a quick question, it's a little bit more maybe high level, but just how do you, when it comes to testing, how do you decide, how do you guys do it here internally? Does the company set a certain standard, or do you, as you're writing the software as a team, do you like agree on what the test should be, what level of testing should be? Are you given flexibility on deciding your test, I guess?
Like most things, it's all different on a team. It's really a matter of as long as it gets tested.
Okay.
Right? I said that's my approach, and some of the testers probably have a better perspective on that. It's really a matter of ensuring that it does what it's supposed to do, right? And if that means that you write the test or someone else writes the test, or that's really where it goes, right? And the way that you figure out what are you supposed to do to test it, right?
Sure.
The metric I like using and the trick I like using is if I were to not have a test, how would I test it? If I don't have an automated test, if I want to see that the color on the page is blue, how would I look? How would I see? I load it and see it's blue. That's how I test it. I read the test just look, do that, right? If I have an application, when I log in and I provide the wrong credentials, it gives me a 403 response. And I go, okay, cool. That's what I just did in my browser. Well, guess what? You just figured out how to write the test, right? It's just automated tests are just replacing you from clicking a billion times, right? The best thing, that's why automated tests are so cool, because they just do what you do. They just are you. Thank you. Okay, that's cool. Let's all stare. So I know you guys are like Ruby world, and you guys are some real world mixture here. Are there challenges that you've come across in testing? How do you solve it?
I found that a whole platform is microservices, right? So we decided to make the code to not mock anything. We were able to do that thanks to Docker. We pretty much launched an instance of the long test. We just launched an instance locally. Your machine, it could be 3-4 services that you're talking to, and they get destroyed once you're done. So that has saved us a lot of time because we were doing a lot of mocking unnecessary. We were trying to simulate what database is supposed to do, stuff like that. So try to not mock anything as much as possible.
Yeah, that is an approach, and it helps if your services that you're working with. Because some stateless side effects are really hard to test for, right? So that's a good approach. I like that style, but it's not. Because you're able to do it because you started from like brand new, right?
Right. So I was able to do it because of
from the very beginning.
From the very beginning.
A lot of approaches to testing, you have to do from the beginning, right? You can have a goal that you want to get towards, and hopefully you can get there, but you do the best you possibly can, right?
Question, quiz question. How do you test that your map access is right? Because map access is in Go randomized, right? How do you test that when you're actually working with maps that you don't depend that they are in a certain order, you know?
Well, that's really hard. Really hard question. I know that the runtime itself actually randomizes for me. So there's that, right? You are guaranteed that that is random, right? They do their best on that specifically because it's so difficult to test for. One thing you could do is, it really depends. I don't even.
Actually, I had the same interesting case because when you do that kind of condition, when you have it, it seems like you have a race condition because suddenly your program behaves like it's racing somewhere. There is like a race condition, but there is no race condition. And you like check, there is nothing like that. And you find that you have a map that actually, whenever you run it, it's randomized, and every time program acts different because every time you iterate through that map, it gives you different results.
I feel like you've had this happen to you before.
Oh yeah.
I've never had this.
It's because Go map access is randomized.
Right.
So I had previous code in previous versions of Go that did not have this. They changed runtime. And then I upgraded, suddenly my code is broken because it depended on
your code
sequence.
Did you intentionally make that assumption on the ordering?
No,
it was
like, accidental. It was like, oh, it's working, it's fine. And then I upgraded Go a couple versions, like, because I started from Go 1.0,
right.
I upgraded to like 1 point something, and then.
That's interesting.
Yeah, I don't actually know how you would test that.
You write your own version of map that's intentionally different than the, and you test it with both. I'm just kidding. Oh, that's not good either.
Yeah, I mean, one thing you could do is essentially reinitialize that section a few times and just try to run it.
And it's actually such a nasty bug because I would spend like a days looking for it, and I had like channels and all that stuff, and it seems like some kind of race condition, but it's not. It was just a map.
Wow.
So sometimes in that case, what you can do like I know some people like using debuggers. I never got the hang of them. I do print line debugging. Right? I just put the print statements all over the place to trace what's going on, right? So you could also put, let's say, an indicator in that would every time it gets hit, it goes, okay, I got called from this function, I got called from this function, I got called from this function, to try to see if the data that's coming in, if you're like, oh, that's a weird order, right? And to check the input. I've seen that tend to crop up in like, let's say you have a map of like URLs to handlers and they're like dependent on each other or something. That could kind of sort of happen because one initializes something and the other's not there. The other thing would be is to say, so essentially unroll that map and call them in an order, then do it yourself, call them in a different order, and do that a few different times and see if you can kind of get it to do it again. Right? It's those kind of Heisenbugs are the worst kind of Heisenbug. My favorite ever Heisenbug that I had was, well, I don't know if it's necessarily a Heisenbug, but we had on the front page of our application, it was Rails, not Go. We had a page that would show you your stats, right, for the past 30 days, right? So how your performance of this your traffic was doing for the past 30 days. Pretty straightforward, right? 30 SQL queries or whatever, however it is, go ahead, ask Rails, give me the 30 days worth and show it on a pretty graph. But all of a sudden we noticed, if you ask for like any time over about 60 days, the entire server would crash. I mean, everything would grind to a halt and just stop. That's weird. And it's just all of a sudden, like we haven't touched that code in weeks. What happened, right? It turns out we found an unexpected undocumented feature, or maybe it was documented, we kind of skimmed over it, right? I found that a lot in Go where it's like, why did it work? Oh, it's in documentation, right? So it was probably in there as like a tiny little thing, we didn't see it. But basically in this case, the issue with duck typing in Ruby versus static typing in Go is when we used, it was like today minus 30.days.ago or something, right? And then we did two, like when you iterate over that, we turn it into a range. For whatever reason, it decided to make that range in seconds. So if you asked for a year, you got 525,600 times 60 queries, and it crashed the application. It just blew up. And we're like, oh, that's cool. And of course, we couldn't find it. It took 4 developers 4 days to find it, 3 or 4 days to find it. In the end, the only way we could find it, like we did everything we could, is we used, if you're not using version control, you should, Git. Fantastic. Git bisect is your friend.
So Git bisect, that's good.
Git bisect is a really cool tool, right? That basically what you can do is say, okay, things are broken now. They were working before. So you kind of look through your history, like, I know it was working 6 weeks ago. You pull out that commit and essentially start Git bisect. You say, this is a known good and this is a known bad. And it will help you do a binary search through your entire code base and through your entire commit history. So it'll go halfway through and you run your tests. Or you do whatever it is to reproduce that issue. In this case, we just went to the home page and we said, okay, still there, right? So you tell Git that's bad. And then it'll jump to the correct to one side, right? Do the same thing halfway through, good, bad, until you basically narrow down through a binary search on one commit that caused the issue, right? So as soon as we found out about this cool tool called Git bisect, we solved it in about an hour. Right, so we went for like 3.5 something days, and also we did Git bisect. Oh, that's cool. Yeah, don't do that. So all we had is like a 2 date, and it fixed it.
Do you guys have a Go? And if so,
yeah. So this is Joe asked me to bring this up. So we've been working on it for a little while of contributing back to the open source community. Right, so we're still getting it set up a little bit, but we have the go-ahead from big company. It takes a while sometimes to make certain things happen. But we will be having repos very shortly. One of them is called Ultipackage. I wrote it. It's to solve a problem that we had here. Basically, it happens a lot where in Go, right, in the Go get, the package man, it's not really package management, it's collecting your dependencies, right? It doesn't do the other half of package management, which is like specifying versions, so it's not bundler by any means, right? But it lets you get your dependencies. But it makes a bunch of assumptions, right? So one of those assumptions is you're using a valid TLD, you're using github.com, you're using gitlab.com, you're using some preset thing at the standard port, standard path. Like it has a lot of expectations. But internally, we don't use that stuff. We have non-standard ports. We have custom domains that are internal only. So we couldn't use GoGet inside the company, right? Which really hinders things in Go because you're encouraging like little packages and stuff and kind of apply the open source model to design. And it was getting in the way, right, of our Go fun times, right? And it was hindering the adoption of Go here at Ultimate Software. So we created a tool. I created a tool that basically just lets you take another domain. In this case, like we use some domain internally. That's a real domain on the correct port with SSL. To essentially instruct a GoGet how to actually get the dependency, right? So it essentially translates that request into the crazy thing that whatever it is crazy compared to Go, what Go expects for it to do it. So this way, if you're running your own source code somewhere, you're hosting it somewhere else, you can still actually use the Go tools to get your packages and stuff. So that's one of the first that we're going to be open sourcing. That is Go. We have a few others that are .NET and a few things like that. And we're really trying to make a big push to get more open source stuff.
So put the pressure on Ryan to get that up on the GitHub page.
Yeah, that should be up by Monday. So we've had a bunch of phone calls and on calls. So it's a little hard to work on stuff at home or when you are on call, but that happens. So yeah, it should be up by Monday. Fully tested. I think it has 90 plus something code coverage. Not that it matters. I know I'm like, oh, bragging about code coverage. No, but it's just this happened to be doable, right? In this case, I could test the edge cases and it exercised the whole thing. I'm like, cool, right? I wasn't trying to do that. It just happened because of the way that it was just structured, right? I got lucky. But it's also a fairly trivial application. The less trivial application is, the lower your code coverage tends to be. Right? I think once I managed to get 100% in a Ruby thing, it was a nightmare to get that. I did it as part of a bet. Someone said you can't get 100% code coverage on this. I'm like, watch me. So I got a beer. Like that was it, right? So, but yeah, that wasn't so good to make changes on, and I regret it. But whatever.
So stay tuned.
Mm-hmm. Yeah. So, but that'll be there soon, and I'll put it in the Slack channel. But it's just github.com/ultimate software. The organization. I don't think there's very much there right now, but there will be. Do we have the stickers somewhere?
I can go get them.
That'd be cool. Does anyone want stickers?
Yeah.
Okay. Yeah.
I'll be right back.
Computer stickers. See, I'm all about them. Oops.
Yours is buried under them.
Yeah, I purposely I decided I wasn't gonna put any stickers until I had so many that it looks like one of those travel cases. So any other thing, not necessarily related to testing, Go, your own projects, what are you working on, what are you playing with? Anybody playing with Go? Yeah. Cool.
I guess I can ask you, when can I start using it right now in my small little projects? When does it make sense to start using
Go?
Yeah.
I use it all to any chance I possibly can, no matter how trivial.
No matter how trivial it is.
Yeah, there's something that I was making, and I first I was doing it, and I wrote a rake task to like do some, I don't know, stuff I didn't feel like doing, right? I'm like, dude, I gotta go. I just wrote it in Go instead. I don't bother, it just depends. If you want to play with it, go for it. As trivial as it can be,
For a small command line application, terminal application, it's a good. That would be a good start.
Okay. Cool. Yeah, because I think I'm making the association. It sounds like super. I don't want to associate it with. I'm gonna have this crazy project that I can then use.
Oh, not at all.
So it's good to start playing with it.
Yeah, and I'm not gonna lie. The first time that I found about Go, I thought it was dumb. I was like, I don't need that. I've got Ruby. Ruby's so cool, right? I can monkey patch. Monkey patching is cool. I can meta program. Oh man, I can be a wizard. It's so cool. So much magic and unicorns. And if you've done Ruby, it's all about magic and unicorns, right? There's like their logo is a unicorn shooting rainbows. Like, come on. But so I thought it was so cool. And then we ran into a business case where Ruby was too slow. A few of them actually. So the one we ran into is we had a CDN serving videos, right? And we wanted to process the logs to find out how much to charge people, right? And Ruby was so incredibly slow for this. it would take us like 10 minutes to do like minutes worth of logs, or 10 minutes worth of logs. Like it took us overnight to process these logs. So we had to be a day behind just to process the logs. So we said, okay, my coworker, we said, okay, you write it in a new version of Ruby that you can do, make it better. And he said he's gonna write it in Go. He had it in a couple hundred lines of Go, and he's never written Go before. Not only was it faster, it could process the entire day's worth in about 2 minutes, and it could also take them pre-compressed. Didn't have to decompress them. On the fly, it could figure out which one to use. It was incredible. I'm like, that's cool. I'm not sold yet. Right? I'm like, that's nice. That's just raw data processing. We're not going to switch anything to that, right? So then we had another task, right? And this is the one that finally sealed Go for me, that made me switch to being a Gopher, right? And I'll write Ruby. I like it. It's a cool language. I like playing with it, and I enjoy it. But I know some people don't like. It kind of feels fun to monkey patch things, right? It kind of feels fun to be a wizard, and Go skips all that. No wizardry's not accepted in Go, right? You don't be clever. But the thing we had to do is, again, had a video player, and we wanted this that when you press, like play, we track that. So like we can say you've had 100 plays today, right? Sounds trivial, right? How hard is it to update a number? There's a fantastic talk from GopherCon last year about an application called Prometheus, which is to do metrics, where he talks the entire time, how do you update a number? Sounds so trivial, +1.
Right.
Except before you have race conditions, except before you have multiple things trying to update +1 at the same time, right? You have 2 connections from the outside world trying to update +1 at the same time. How do you track both of them? It's not easy. It's surprisingly not easy.
Right.
So we did it in Ruby for, like, again, we did another competition. I did it in Ruby because I'm like, yeah, Ruby's so much better. Why don't we have another tool? And we couldn't spin up enough Heroku instances to handle it, right? We had so many of these Heroku instances, and then none of them could handle it. It was choking. So we rewrote it in Go, less than 100 lines of Go. We could saturate the network connection on the server before it even complained. It was using less than 5 megs of RAM. It was using less than 1% CPU. It was not touching the disk at all. It was stateless, and it worked beautifully. And we never had to touch it again, right? And then we could write tests for it, and we never touched it ever again. And it worked for years, right? And that's when I was like, okay, I'll give this Go thing a chance. Right? And it's not, the thing is, what's cool about Go is there's no magic to it, right? And by not having magic, you get rid of trying to be clever and get to focus on just solving the problem. Right? In Ruby, part of the community is let me solve it in the most clever way possible. When you write code to write code, now if that's not trippy, it doesn't send up red flags. That's a little weird, but it definitely is. I'm not gonna. You guys learning Ruby, so I'm not gonna say too much. But it's fantastic. I like it. It's a very cool language. You do a lot of very cool things with it, and it's fantastic. If you learn Ruby, you can understand object orientation in a way that few other languages can do. Right. At least that style of orientation.
But I kind of what you're saying. Like I did an exercise with Austin's our teacher.
Bunsen?
Yeah. So, but I sat down with him on a one-on-one, and he had me basically like rewrite the index method, which wasn't probably pretty simple. But, I'm super tired. It's the middle of the day. I can barely think, and I'm trying to do this thing and working logic. But it was useful after because it showed me the complexity that Ruby hides using like one of their methods or iterators.
Yeah,
very Ruby-like. Right?
In fact, in Ruby, you can make 1 + 1 = 1. You just literally can patch numeric, I believe, and override the plus, and then say if it's this, do this, haha, otherwise it's called super, and haha, now you just ruined everything for everybody. Right. You can do that. Like you can really mess things up for people. You can just open up anything at any time, and it stacks. Right. Anybody can do anything at any time, and it's very difficult. Yeah, you can make true equals false. Right. You can do all. It's cool. It's really neat to do that, right? And it has some very powerful things. You can make TSLs with it. You can write your own language in it almost. But at the end of the day, ain't nobody got time for that. like I just want to write my code, it to work, that I test it, that it works, that my tests pass, and I get paid. Right? I don't need. I feel like I've gotten beyond trying to look clever for the sake of being clever. Right. And having to do 10,000 things I want to get the job done, right? And I want to do it in the most efficient way possible. And for me, I like using Go for that, right? And in other instances, Ruby's a fantastic choice. I wouldn't hesitate to use it. In other instances, Java or C or Rust or so many languages to choose from. So it's really just the best tool for the job. And I think Go is designed for a lot of the work that the typical companies use software for. Right? It was made by Google to solve Google's problems. Like their Google problem is no different from yours.
Sure.
They just get 20% of their time off and get self-driving cars and stuff. Other than that, your problems aren't really different, right? Unless you're NASA.
So is Go your preferred language?
These days, yes.
These days?
I started a long time ago. Not that long, but to me, it's a long time ago. I started with C++, because I started studying electrical engineering because I wanted to make robots, and the way that you do that is microcontrollers. And microcontrollers, they speak C, right, or assembly, or BASIC, or things like that. These lower level languages. And kind of roughly about the same time that GeoCities was a thing.
Wow.
Yeah, I was making HTML pages. I'm like, that's cool, but this is really, really repetitive and boring. So a friend showed me PHP, and I'm like, that's cool. It does everything for me. Nice. And then I just kind of went from there. PHP to, this is before 5. This is like PHP 4, PHP 3. Right. So it really didn't have object orientation yet. It was very clunky compared to today. It didn't have all the stuff that it has. Jumped to Ruby. Fell in love with Ruby because it's better than PHP. That's not saying much. I'm sorry. And also did JavaScript and things like that. And then I was like, okay, all this stuff is cool, but I want types. I want a statically typed language. I want something that compiles. I want a compiler to find my problems for me. Duck typing is cool, but it's at the end of the day kind of annoying. When you're trying to get stuff done and suddenly you're getting weird data from somewhere and it's not what you expect and it just kind of explodes, right? Go won't let that happen. If you expect to receive an integer and you get a string, it just won't compile.
Yeah, right.
Right? It just won't. There's nothing you can do to make it compile. It's like, screw you, you messed up. I go, oh, okay. Right, and I fix it.
Right.
I can do it with Ruby. I can do it all day with Ruby. Right? I can put a string, if I do 2i, just to be safe, I'm going to make it an integer. The integer version of a string is 0 for some reason.
Yeah.
Right. Yeah, and nil is also 0.
Nil 2i is 0.
Yeah, but there's a fantastic talk. I think it's about Ruby or JavaScript, and the only thing I remember is he had this lady.
It's literally the WAP video. It's the WAP Google search WAP video.
What all these weird things that they just decided, and that's JavaScript mostly, but Ruby has it too. Go has it too in there somewhere, but from what I do day to day, it kind of does what you expect. And when I look at packages and frameworks, I try to not use frameworks so much. When I look at packages and code, I kind of just go, would I write that? I can look at the code and say, would I write? Is that how I would do it? And I go, okay, cool. I would do it that way. So yeah, sure, let's use it. Save time, right? Whereas
That's part of the power of Go, though. The idiomatic nature of it. You can only do most of it one way. You're going to wind up with the same solution. I mean, funny internal conversation. So we have a Go programming test to come into the company, and I took it and gave it to 4 other Go developers, and all 4 of our answers you could have put in beyond compare, and it would have been off by maybe a line. So, and it's not a trivial example. So,
yeah. Plus, have any of you? Do you ever watch Silicon Valley?
Yeah.
Okay. Yeah, I'm just making sure. So this season, there's a thing of tabs versus spaces, and you can't handle it. Why would anyone use spaces? They just convert it to I get angry about that, right? Go says, yeah, that's nice. We have a tool called GoFunct. We run it. We expect everyone to run it. It just sets the format. We do not argue about formatting in Go because it's just preset for you. You can do it however you want, but the compiler and the formatter is gonna, before you save it, it's going to change it. It will rework it and be the exact way that the language, the guidelines of the language are, so that your code doesn't look different from your code, doesn't look different from his code, and it's surprising the amount of byte shedding that leaves out. Right? You don't have to argue about. It's such a weird thing to argue about, but we do. Right. Tabs versus spaces.
Four tabs or 2 tabs.
Yeah.
2 spaces, 4 spaces.
In Ruby, your hashes are you use strings or symbols, right?
Yeah.
Are you gonna this? In fact, in active support in Rails, you have something called with indifferent access. That basically is a giant monkey patch conglomeration thing that basically makes it so that you can use symbols or strings, and it'll just figure out which one you meant, right? Which is cool, but come on, man, like why did it do like come on, like that's silly. Like why do we have to have that argument? Whereas in Go, it's like, yeah, that's nice. It always works this way for slices. It always works this way for maps. It's typed. Your types have to match. Doesn't matter. That's nice. You don't get an opinion, right? It's the language style and things that are highly opinionated. So as far as the language itself, as soon as it's now your application, it doesn't have an opinion.
It's like, for me, it's so easy to read code written by other people because like you pull in dependencies and like sometimes you're like, does this thing actually work? Like what's going on with this? It's so easy just to go in there and be like, oh, I actually get this. Like I don't know what, if you guys try to read code written by someone else.
Yeah.
It's often very difficult, especially you're pulling in a dependency. It's like a huge, relatively large project that's relatively complex. I've had great experiences where I'm like, how does it actually work? And I'm like, oh, it's very obvious. It does that. I'm like, okay, that was easy. And I have other languages, it's not the case. It's like not so easy, but it's because Go is so standardized. Even just the formatting, like that makes it so much easier. So
yeah, and
really, really nice.
There's tools like GoDoc, and there's all sorts of good tooling. The tooling is incredible with Go. It's one of the first things I noticed, like, oh, cool, documentation, like it literally renders documentation HTML for me. That's awesome. I don't have to do anything. I just write my docs right there, and it'll work. Go Funct, there's tools to do linting, to do vetting, so that you can see if you're doing weird things that could potentially cause you problems in the future when you're doing special currency. The race detector, there's so many cool things that they're like, hey, what's the bare minimum that we can do to make people productive, to make our developers productive, right? It doesn't have to be fancy, it just has to work, right? And that is something that I really, really appreciate that the developers of Go, or creators of Go did. Fun fact with that, the creators of Go, the three guys, Rob Pike, Rob, the other Rob, and the other guy, I can't remember.
Breeson and Ken Thompson.
Yes. So these three guys at Google were like, we're going to make a cool language. And there's another talk, GopherCon, and some others about the history of Go. That some of these guys, they made like languages you've heard of, right? Like Pascal. Some of these old school, real classic languages that we've heard of. They kind of said, let's take a little bit of all of them. And then what they did is they literally said, we're not adding a single feature to the language unless all three of us agree. When's the last time two people agreed about anything? Right. So as a result, the language just doesn't do any more than it has to do, and they refine it and try to make things as you would expect. But you don't necessarily need to know. PHP is horrible about this. If you ever have written PHP, the inside, even the array stuff, they're all different weird things, right? Even stuff to like join an array. You can put them. You can put the arguments in any order because in one release they screwed it up, so they had to provide backward compatibility for either. So you can put the array in either one, and you can put the glue in either one because they just decided, yeah, that's great, right? In Go, it's not like that. Like it's strict. It has a real spec. It's actually readable. It's fairly small as far as languages go.
27 keywords, I think.
Yeah.
Compared to C++, which has 88.
Yeah, and Ruby, which has a buttload. And you do more all the time.
But there's no package manager, Ryan.
Right. So, but the thing is, when you think about it,
That's actually legitimately that's
Yeah.
annoying.
there are a couple guys that big people have. You will hear complaints about Go about what's the one generics.
No generics.
No generics. No generics.
That one I'm less.
What I've done,
Okay.
I've never really been like, I really hate generics. But that's just what I've come across. So in their generation, they never needed it, right? And what they're doing, there are implementations, there are ideas of how to bring it in without adding too much complexity. I don't even really understand it completely, but there's that. The other one is the package management.
That's the one I have the biggest beef with. It's like legitimately really annoying.
So and a lot of these things, I like the approach that the Go authors and the Go core team have done, which is basically, hey guys, you're using the language more than we are, right? Or just as much. We can't possibly predict and decree from on high how you're going to use these things, right? So the community kind of comes up with a bunch of different techniques. Recently, that happened with vendoring, right? So there's a big thing of how do you ensure that your dependencies are what you expect, right? In Ruby, you have bundler for that, and a gem file and gem file lock to try to at least ensure that when you pull in this function, when you pull in this library, then when you go to do it again, you're going to get the same thing, right? So Go didn't have that. You're pulling from the Wild Wild Internet, right? The Wild Wild Web. And it was a problem. How do you solve that, right? So there are a lot of different approaches. One's adding something like a gem file lock. One's adding something to the language. In the end, we basically said, we're going to separate the two concepts. Where the code is we're going to separate location from time. So now the Go standard tooling just worries about location. It'll get your code, whatever, but your Git repo that's vendored has the time aspect to it, right? So your Git repo says, okay, at this point in time, my dependencies work like this, right? At the end of the day, that's really what matters, is the dependencies work how you expect, when you expected it to, right? There's a lot of tooling that opened up around that, and now that's part of the language. It was introduced, I think Go 1.5, it was an experiment. Go 1.6, 6 months later, it's part of the language, and in Go 1.7, you can't turn it off, right? So they roll out features like that. It came from the community. A bunch of people came together and said, hey, this is our proposal. We have a bunch of different ways. So you can use any tool you want to manage the vendoring, because the community came together to do that. And one doesn't necessarily want, but at least you have the tooling there, and the compiler and stuff will recognize it, right? So that's one example. Generics, another one people are working on. There's a lot of different ickiness in some places that people want fixed, so they just come up with a way to do it, right? And that's, I think, something special about the Go community versus the Ruby community.
Right.
There is no spec for Ruby. The Ruby is whatever Matsumoto says it is. It literally, he just that's cool, I'm gonna add it.
Right.
And there's no spec. And it just sometimes wildly changes. It's like, oh, I feel like doing this thing, cool. And so that's why you have 50 ways to do things. There's a for loop, but you're not supposed to use it.
Right,
You're supposed to use each.
right.
You're supposed to, and don't use, you wanna iterate over your own collection? Enumerable, there's a module, just pull it in, enumerable. Oh,
Right.
So there's each with index, each key, so many different ways,
Right.
And none of that, there's functions. You can do functions with def, you can do a proc, you can do proc new, you can do a block, you can do a stabby lambda, you can, come up, just so many ways to do it.
Yeah.
Because it's just Ruby. Everyone wants to be cool, so let's be cool.
And so when that creeps into a business environment like this,
It's horrible.
It's not good. You have 50 different ways arguments start. So
it's absolutely horrible, because then you have some people who like using stabby lambdas, and some people who like using proc new, and some people like doing blocks, at least in the Ruby world. But on the Go side, I know that never having seen his code, right, I can jump in and fix it. I've never seen it. I have no idea. I don't even know what it does. I just know at the high level what it does, and I trust that he probably has a test or two, because I shouldn't have to be afraid of my tests, my code, to make changes. So that's not a big part of testing. But I know I can jump in and fix it if I had to, because it looks the same, it acts the same, it's idiomatic, it's documented. That's part of being idiomatic, is that you document.
Right.
You have certain ideas that you're not documenting what you're doing. Code tells you that. You're documenting why. Right. So I know I can jump into his code. If he was writing in Ruby or Java, I wouldn't.
Right.
It would be horrible. I would be like, no, that's nice.
Well, then you're gonna take the extra step to see what was he thinking, writing it this way?
Right. Yeah. You can tell a lot about a person by how they write their code. You can read someone's code and say, okay, he's gonna be a cool guy. It's once you read a lot of code, you can kind of be like, okay, yeah, I can get along with him. And you see it's like that craftsmanship thing, right? If you see that someone really cares about something,
right?
When they're doing what they care about and they're doing things in a way that show that they care, coding's unique. It's thought stuff, right? It's not real. It's never real. It's not there. It's an idea that's in our head that we somehow tell a computer that also is kind of, how do ones and zeros do for loop? I don't know. Right? But it does. And we can take this idea that's in our head, that's in our brains, and turn it into something that someone else can read. There's nothing like that anywhere. Right? I can see how you think. How can I learn how to think other than writing code? Right? So yeah, you absolutely can see how people think and behave and act just by how they care about them.
That's so cool.
So I have two unrelated questions.
Okay.
One, how did you get started here? And two, more unrelated to one, is I saw game room. Do you have napping pods as well here?
We don't have napping pods. Actually, we do. They're called cars. That's the thing. Here we strive, at least Ultimate, to have a work-life balance. So generally, you shouldn't need, you come to work, right? What do you need to take a nap here for? You're not living here, right? You live at home with your family and life, right? So we try to avoid those long swallows that would require a napping pod, right? It's just one of those things, like if you care about people, don't make it so they have to sleep at work, right? Sleep at home, it's comfortable there, right? You have like your stuffed animals and stuff. But the first one, I got started here, actually, I credit this meetup for it. A friend of my mother-in-law's actually said, oh, I work at this place called Ultimate, it's really cool. It's like the Google of South Florida. You'd love it there, you're a cool developer, you have skills and you know what you're doing. So I'm like, okay. So I applied. Because I had heard about Ultimate before, but I heard it was a .NET place. I'm like, .NET. Not my thing. Huh?
So it's not .NET?
Oh no, we're .NET, but we're not only .NET anymore, right? Several years ago, it was .NET or bust.
The wall fell about 3 or 4 years ago.
Right. So
I heard everything's Windows here. Sorry for interrupting.
No, some of the core stuff is still when we're teams get to choose for the most part. A team that Baker's on over there chose to go with a lot of Go.
Yeah.
Or at least he used to be on. He chose to go with a lot of Go. Other teams, there's at least one. Only reason I know is because I'm on the team that does the deployment, that like works on the platform layer, so I know what everybody code they use. Some teams use .NET. Some people use .NET Core. Some people use Node.js. There's
Java.
1 or 2 Python things. There's Java. There's a couple Ruby things, and there's several Go things. And we have guidance of like, hey, I want to use this new crazy language. Can I use it? And you pretty much talk to the architects and be like, make a use case for it, and they'll figure out if it's cool, right? So when I found out at Ultimate, when I found out it wasn't just a .NET shop, and there was some stuff more on the platform side where I like to be, building tools for other developers. I like doing that. I found that there was an opening for that. I applied, and then I came to a Go meetup randomly. It was like my first time, and a guy from Ultimate was talking about this cool thing that he made in Go, and I said, hey, I just applied like 3 days ago, and I haven't heard back yet. He's like, who's the name of your recruiter? I gave him the name. He emailed him, and I got a call the next day, and we to basically be like, hey, ran into this person at a meetup, and I was able to get into an interview. And I'm not saying the guy clearly didn't say go hire this dude. He showed up to meetup. I'm not saying that, right? But it's basically I ran into this guy who worked at Ultimate, who basically said he ran into me, said go talk to this guy, he cares, right? And then through an interview process to care of the rest, right? So I've been here at Ultimate for a little over a year, like maybe 14 months or so, and it's awesome. The honeymoon period hasn't worn off yet. That's cool, right? And that's important. You did not interview me, but Mikhail and his wife did. That was a little weird, but I didn't realize.
They interviewed you? Wife team?
I didn't even know.
We're fairly incestual at Ultimate.
In a good way. In a good way.
In a good way.
Careful how you say it.
There are a ton of husband-wife couples here.
Really hot.
Yeah, and we're
They get
people
the
first
first
is
skills.
literally like you'll see it everywhere. Like here. Oh look, I'm gonna borrow this for a second. Ultimate Software, people first, right? Like it's everywhere. People first is what we do. It's our approach to software. It's our approach to running business. So take care. Like we're a family, right? I see like the CEO like say, hey, what's going on, right? Have a drink with him. He's the #1 rated CEO in tech in the country, right? Like I can just go talk to him if I wanted. I don't think I would because I'd be a little, but I could. I'd be like, hey man, what's going on, right? Or if I have an idea of how to like help the people here, I know I can talk to his wife, who's also like a C-level position, send her an email, and she will respond at 10:30 at night. Yeah, right. That's happened.
She doesn't sleep.
Yeah, I don't. She's not human.
At all.
Right. I do not know how she does it. But they're the driving force behind this, and the CTO is the son-in-law of the CEO. Yeah. So it's definitely a family that's brought down. It's a family and kind of like a sports team at the same time. It's kind of an interesting thing. In fact, at the headquarters, which is down the street, this is phase 10. I think there's 12 now. 11. There's soon to be 12, but different locations in Weston, right? That's not counting all places anywhere else, but in the headquarters, the central area is a basketball court, right?
I went there. I made a mistake. I went to the main building. I saw them playing.
Yeah,
I thought, is there a go meet up here? I said, no, not here.
Yeah,
you play some basketball then.
Yeah, he almost said that.
Yeah, so they take care of their people here, the people first, like all the way through. Right? And it's not just .NET. it's really the best tool for the job, right? And that's really what being a pro. Like, that's what it's
If
about.
it helps the person who has, I mean, we're hiring.
Yeah, like constantly.
30 a month, I think at this point.
It's
now.
like 100 something a quarter.
Yeah.
Or every
So
2 months.
You're hiring, that's how fast you're growing, like 30
people a month.
When I was hired, there's probably been 600 people hired since I was hired.
What?
Yeah, it's
Where do they all go?
This new building.
They build new buildings for us.
And we're trying to buy out the 2 next door. So.
Yeah, so they.
Oh, I did apply for the internship.
Okay.
The company's nearly doubled in size since I joined 3 years ago.
There's
We just hit 3,000 recently.
We're
more than
past-
3,000
we're
now.
way past that.
But I mean, they celebrated that like
beginning of the year a couple months
I think we're at
ago.
3,500.
Yeah.
When I started, it was 400 and change. That was 10
Yeah,
years ago.
and our product manager was employee number 70, and he started 20 years ago. So it's
It's a black hole of employment.
yeah.
Really?
It's good about
No one being supposed to get here. It's
people joke that the only way you get a promotion is someone dying.
That's not true at all.
It's not true, but like people are here for a long time, right? People are loyal because this is one of the few places that they tend to be loyal towards their employees and they take care of you. So
Yeah, that's funny you mentioned because you don't really hear about tech maybe in general or some big turnover.
Our
That
turnover
whole
rate is less
2-year
than 4%.
turnover average in tech, like
Yeah.
we'd blow that out of the water.
That's
we have like a 97, 96, 97%
Yeah, somewhere in the
retention rate.
90s employee retention rate.
And that
That
includes
doesn't
people who
include
vol-
retiring.
Yeah.
Like people that leave voluntarily. I think it like
leave voluntarily or are
4%.
That's
Yeah, so I mean, the interview process does a pretty good job. They take care of their people, right? People first, all that stuff, and it's incredible. It's literally the Google of South Florida, Google of Florida.
so cool.
So yeah, that's our ultimate is awesome part. Part of the talk.
That wasn't planned.
That was
No,
not.
that wasn't planned.
we
I was
generally
just gonna ask. Oh, so you guys selling this stuff?
no. I generally there's a conflict of interest. I work here, we host it here. I don't like necessarily being the host of it and the talker. The speaker, I would not do that under normal circumstances. Mainly, the only reason we did it is because the person who was originally going to give the talk had a commitment that came up at the beginning of the week. So I didn't want to push everything off, right? So, and if you have a topic you want to talk about, like it doesn't have to be pure Go, right? One of the things that I've found is there's no such thing as a pure anything developer anymore, right? If you're writing a website, doing Rails, you're also doing JavaScript, you're doing CoffeeScript, you're doing possibly Haml, you're doing some other SAS, you're doing a whole bunch of things.
Right.
Yeah, you're doing, you're doing SQL, right? You may drop down to SQL. You're no longer being, I'm a SQL developer, like I just write SQL all day. No, right? We don't do that, right? Being a polyglot is kind of where it's at, right? So that's, if you have anything that's like here, I didn't have to go into a lot of details of the Go mechanics because that is easily replaceable, right? So if you ever want to do, just send us on Slack, message on Meetup, message Bill Kennedy or myself, and we'll see what we can do. And so this is a new format for us, right? We used to just do 1 or 2 talkers for 20 minutes. Do you like this? I know there's a lot of new faces here, right? But we're trying to we're trying to improve. We're trying to be agile even in the Meetup thing, right? So does this format work?
Well, maybe for WinCode because they're so used to like working a lot.
Okay.
Some meetups in South Florida do like live coding things, which might be interesting. Maybe some live coding and Go.
Yeah, we can do a little more hands on some stuff sometimes, some live coding things.
You go through Ulti package.
I could go through LT package. It's pretty cool.
You're pretty biased to that.
I am pretty biased, but I've also rewritten it 4 times because I wasn't happy with it. I wanted to make it better and better and use less and less.
That's craftsmanship, right?
So, and I got better tests, and so one of the things that are requirements is just oh, that's really tiny. That on the left is the presentation, by the way.
Oh yeah.
So yeah, it's a tool written in Go. Look how dark I am with those things black. Where was I going?
The presentation tool is written in
Oh, the
Go.
presentation tool is written in Go. That's pretty neat.
Turns Markdown into those pretty
Well,
slides.
sort of, yeah.
Markdown-esque.
What's the name of the tool?
Which?
Presentation tool.
Called Present.
Present.
Sorry.
Easy enough.
Another idiomatic thing in Go is that you try not to stutter. That sounds weird, but basically it's not called like present. Like the thing is not, you don't say presenter, or factory, or the package is called factory and it makes like you don't do that, right? You try not to, that's called a code stutter, and we try not to do that, right? Code present. Let me just do this instead, so you can see it. That's big enough, maybe. Oops. And I do a whole bunch of stuff on the shell, so don't mind me too much.
Shell is awesome.
Yeah. Something I want. Oh, you have a rig file, what do you know? So, oh, that was all my dependencies. There's 65 files, like that's even with every single dependency in the entire system, right? So the actual thing is main Go, repo Go, and templates Go.
Is that a power line user there?
Yeah, it's only Z shell.
This one.
So this wonderful, yeah. We've got some, this is kind of, I don't know if you haven't seen Go, this is what the imports look like. Some configuration stuff. I have a little package that does configuration and some overriding that I like to do. Lets me create a 12-factor app. You've probably heard that term. If you haven't, you will. I have my logger. I do all that stuff. This version, the compiler actually injects that when I compile it, so I can track in production what's running, which is kind of fun. So there's that. And then I have a little bit of setup, and my main actual thing is here. So I start up a non-secure and an SSL-based server right here that has one. There's one handler. There's one actual code, right? This is mostly boilerplate here, but I can get my configuration. I log copious logging because in production, that's all you have in logs, right? This stuff here is actually for concurrency. So I basically keep track of the fact if you do anything concurrent, manage it. More SSL. SSL is trivial. And here is the actual meat and potatoes is right. Can I get it all in one thing? Probably can. Right about here. If I took out comments, it'd be even less. But that's readable. That's what GoFumps does. If you spend a lot of time, you say, okay, I build up my repo thing and I check how the part components and I list what they do. I set my content type and then I pretty much just render it. Like that's 99% of the logic is right there. Wow. Right? And this can serve, I have no qualms about this serving thousands and thousands of requests a second. Right? I don't think you could take this down. Right? You could hit it with thousands of, you'll saturate your machine. Your network connection will not be able to keep up with what this can handle. I'm confident of that, right? I've never tested it, but I just know that based on the fact that how I've seen it perform in the past, and that this is not using anything external, right? This is not using a database. This isn't using anything else where I have to worry about performance. This is just basically taking the URL, manipulating it, and writing some metadata, right? It's trivial. So as a result, it is small. Yeah, that is actually kind of the whole thing. And I log some information about it. That's it. And let's see. 150 lines for that, including all comments and white space. And then why not? I think this will work. There might be some extra stuff in there, but it's less than 300 lines, and I have an application that I can't kill in. And we've had this in production like a year, since I wrote it, we've had it's a slightly different version.
Right.
It has some internals that we can't like share kind of stuff, but it's essentially this. I haven't touched it in a year. Like the network had an issue before this did, right? Like it doesn't have a problem because it's so tiny. Its surface is small. We don't worry about it ever, right? I've never had. I think in the entire year we've had a person complain once that it didn't work, and that was because the network died. And so we can see what tests look like. Yeah.
Like commented out code.
Yep. That's because I just messed around, I guess. I'll make sure that's not there.
Free open source it.
Yeah. So that we'll see. I might just leave it, benchmark it properly. Right. There's probably a reason I commented that out. I don't remember. So I basically do some setup. That's the test main lets me do my setup. I create like a little helper struct. Go doesn't have concept of a class, you have concept of a type, right? So your type is, in this case, an outcome. That's your type. And it contains a path, a couple different paths as strings. In fact, in memory, that's 3 strings, right? Like part of Go is, I could go all day, but part of it is the idea that, what's the term that Bill always uses, is that it's readable. You understand. I know if I want to think about it, down to the processor, what's going on. Exactly how it's stored in memory, I can just be like, okay, cool. It's going to store, let's say we know a string is, 16 bytes, for example, another 16, another 16. So that's whatever 16 times 3 is, that's how much memory it's going to take. And I know precisely how it's going to be written and how it's going to work, right? And I'm able to do that based, because just the way it's structured, on mechanical sympathy. Go has mechanical sympathy, so it understands how the hardware works. It does its best to make it easier for the hardware to do its job. So let me just do some stuff for me to do my tests. I create a whole bunch of scenarios with just a map. And these will occur randomly, like as the question came up, Go make sure that you don't accidentally depend on the order of your maps, and it will randomize them for you. Because they basically said that's a source of problems, right? Because hashes are not supposed to be considered serious, like iterating over them will not come in the same order at any time. So they force it to happen. So you can't depend on it. So I just basically test a whole bunch of different things with my outcome, which is what I expect the individual components to be. I actually create a special testing. Again, this comes from the test package. This is all standard library stuff. Like I haven't imported a single framework for this right now, right? This helper that I made for my stuff says if I get this arbitrary path, run the function that the server is actually executing, which is ulti-package, right? That's the thing that has all the logic in it to do all the rendering. That's my main function, my entry point. Run that, right, for that URL. So I'm testing, in this case, the fact that when I input this thing in the browser, I'm going to get this thing in the body, right? And that's really how GoGet is working here. So then I have my actual test, which is, now I actually do pull in a few packages just to help. So I like using this stexpect just because it's literally the exact same thing I would write. It's like 5 lines of code, right? And it saves me from having to write a huge if statement every time. Again, I just like using it. It's not necessary. In fact, I might rip it out before putting it open source just to show you don't need it, right? And then this other part here is a little trickier. If you ever tried to parse HTML, it is essentially impossible, right? If you try to scrape it, it is the hardest thing in the world to do because you kind of have to bang your head against the wall and be drunk to do it, right? It's something that's evolved over the times of the Wild Wild Web. Like that's just how it works. So there's this cool thing called GoQuery, which essentially sounds kind of like jQuery. Works the same way. It'll take a selector and basically let you traverse the DOM tree. So in this case, I'm making sure that the DOM has an element that I expect. And that is correct. That metadata is exactly what it's supposed to be. That's it, right? That tests right there. This one test function is actually able to do however many scenarios I come up with, right? So if I come up with a new edge case and I expect it to work a certain way, I can just add one line and I've now improved the resiliency. Right? If someone reports to me, hey, I put this weird thing in the URL and it didn't work right, I can put that in here, what I expect it to be, and reproduce it every single time, right? Because I'm using in Go a table-based test. I have a table of outcomes. And I have seen there are good talks about how to structure these table-based tests to do things, but then that's it. And then we can benchmark. So I actually do benchmarks, which is cool, and it's really fast. It's doing nothing. But that's my story. Thanks for coming out, everybody.
Thank you.
I'm a sticker.
If you want them, smoke them if you got them.
The theory of test coming out. Hopefully we'll see you guys again.
That'd be crazy. You guys introduction.
I'm sorry. Yes, that's Go Miami.
Ryan,
What's the Slack channel?
the Slack channel it's Go Miami. Sorry, it's Gophers. The thing is Gophers.
Okay.
Gophers.slack.
Go Miami.
Yes.
Yeah, I'm gonna post on that.
No,
It's all in Git.
Where UF were.
So this is possible.
So I used it until it got shut down, but I was just wearing it now because I think it's. I don't know. Someone that's it. Like, used to work there, like, you even know what GroupShark is? Nope.
Okay.
They're gone.
So-
Oh, no, oh yeah, they got shut down. They were doing cool shit. So,
See, I thought about GroupShark since
I mean, so like, you know, you use GroupShark, it's like too good to be true, right? It's like,
Yeah.
it's got to get all your music for free. It's like you're uploading it. Well, yeah, it was too good to be true. Like they finally got shut down.
So I don't know.
I do not condone what they did, but they.
But your shirt just looks too new. And then once you get that,
Yeah, well,
realistically.
it is a little. It's starting to get wear and tear. I wear it a lot. No, they were. Yeah, they were. I mean, obviously, like the way they're letting people upload, constantly over the rights.
Hello,
And then you came out later, like repeated because they were.
Oh, I didn't mean to.
YouTube. Like you have to upload stuff to YouTube, but if YouTube gets a takedown notice, they'll take it down and actually run the same, do the same thing. But you know, they're not as big as YouTube, so that argument can apply. And also, just came out like brand new investigations that early on they were using momentum for the service. They told all their employees, they found internal emails that were telling all their employees to upload as much of their own personal music as possible in order to, like, because they wanted to build the library, yeah, to gain momentum early on. So when that came out, I was like, all right, well, focus on my business. It's an indefensible position, so it went down like so I was still in school when that happened, and it was like a big deal because, like, you know, all the computer science was GroupShark was kind of like the poster child of like those 2 years who graduated and they went on to like start the school like tech startups that was like in downtown Gainesville, kind of like 100,000 people, very small. So there's like 80 software companies there. They were like the cool people in town, and they got it was a big deal.
You know Matt Dillon?
Yeah, I have heard that there's some people.
Go meet up, show me this dangerous. Why are we getting hurt? So yeah, no, GroupShark.
Yeah, it's a pretty very popular. On your way out, if you look back, on your way out the door, top right.
Yeah, exactly. I remember thinking it was so cool.
Yeah.
The selection.
I am. Every year with these shirts again. I'm like, I want to keep it, but it's like it's not that popular. Like, a lot of people never even.
You get like every once in a while. You work it.
There's a few people. That's what I always do. Someone wants to ask me, so. Let me not do that. You just oh man, you didn't test it. Broke our you literally just leaned it's brand new. This building's new.
Oh, okay.
Ryan, you actually broke this.
I know.
Damn, dude, what'd you do?
Just breaking it.
I was testing it.
Oh yeah, he stress tested it. He stress tested too much.
That's gonna pick up.
Fun stuff.
And I got a break.